I'd like to welcome you to the next lesson, which is on production functions, and more specifically long-run production functions. It's a very important part of microeconomics, and we're going to go from this on a kind of journey looking at how firms produce, the costs of production based upon their methods of production, and then looking at revenue functions, and finally looking at profit maximization. But before we get down that journey down the road there, we have to look at some basics to do with what firms produce and how they produce it. Okay, I'm going to take an example of some nice cookies, so hopefully you're not too hungry before we start this lesson. If you are, then sort yourselves out quickly. These are the learning outcomes. It's quite a short presentation here, but some very key concepts of microeconomics, looking at production functions, where output of, for example, cookies is related or a function of capital and labor and land, the resources that firms have. We're going to look at the difference between the long run and the short run, and this term called isoquant, which I'm going to leave for a few minutes. Likewise the next one. And then of course how firms can produce using different production methods. They can use, for example, relatively capital intensive methods of production or relatively labor intensive methods of production, depending upon the costs of factors of production and availability in markets. And finally, with a couple of MCQs for you to look at. Okay, let's get cracking. Production functions. The output we're going to take as being a nice plate of delicious home-baked cookies, which you can see up there. And we're going to look at a bit of theory here. We're going to have two axes with two factors of production, capital and labor. Don't forget, capital, of course, is physical capital used to make other goods and services. So in the case of the cookie, we're talking about ovens, the fixed assets, for example, and also the raw materials that go into making the cookie, the chocolate chips, the sugar, the flour, eggs, and whatever else goes into making them. They're all part of capital. And of course labor, we're going to have in this case probably the master chef. So we have capital and labor. We have these curves here. These are called isoquants, but I'm not going to discuss them for a few minutes. This particular curve here looks at an output, okay, and we're going to assume that anywhere on this curve, okay, we are producing 500 cookies per day. That's the output level. Now it's called an isoquant because there's an equal quantity. The word iso is a Greek word meaning equal. I'm sure you remember isosceles triangles, triangles with equal angles. And here we have an equal quantity. So wherever you are on this one particular curve, this one particular isoquant, you are producing 500 cookies per day. Okay? Whereas if you move on to the next isoquant over here, okay, you are producing at a higher output level 1,000 cookies per day. So if you're producing, for example, at that point there, you're producing 1,000 cookies a day using relatively capital intensive means of production. You do have some labor, but you have relatively more capital than labor. If you're down here, okay, at that point there, you are producing 500 cookies per day and you are using a relatively high amount of labor and relatively less capital. So an isoquant represents a quantity of production per time period. If we move on to a different isoquant, we have a different production level, and all points on the same isoquant represent an equal quantity of goods for whatever time period we are talking about. And then you can trace out the path which a firm follows as it increases production. So for example, at this particular output level here, it might be 100 cookies per day. The firm's just started out. They're using a certain amount of labor and capital. At this point here, in order for them to produce 500 cookies per day, they have decided, based on factor cost, the cost of labor, the cost of capital, they have decided to use a certain amount of labor over here and a certain amount of capital. And then as they produce even more, they've made some other decision to produce using a certain amount of labor and a certain amount of capital, and so on. So this black line here, it's a bit kind of squiggly as I've drawn it, represents the production function. In other words, the output of cookies will be a function of the amount of capital that a firm has and the amount of labor that the firm has. And I'm going to represent that now by K1 in the initial isoquant and L1 for labor on the initial isoquant. They had decided to use K1 of capital and L1 of labor, but in producing a higher quantity of cookies, they had decided to use K2 of capital and L2 of labor. And those are firms' decisions based upon availability of factors of production in local or international markets, and of course, therefore, the resultant factor cost. In other words, the relative price of factors of production, which we could represent as being something like this. The relative price of labor would be the price of labor divided by the price of capital. We tend to use K for capital in economics because C is used for a macroeconomic variable called consumption. Okay, so there we have the relative price of factors of production, and this will determine to a large extent whether firms use relatively more labor or relatively more capital. So now we write out some of that text. It's an important part of exam technique to be able to draw diagrams and to be able to refer to those diagrams in your discussion, and of course to be able to write out the relationships, not just in terms of letters like K1 and L1, but to write them out in prose, in effectively good, good English. That's an important skill you have to develop. So we're going to have a mixture of analysis of graphs in our lessons, but also we are going to try to write out, of course, in presentations. It's rather more difficult. It's a skill you can develop often by writing out essays and having feedback on them from your tutors. So production consists of inputs and outputs. Inputs are the factors of production. In other words, the resources. We have two here, capital and labor. I'm not ignoring land or enterprise, but I can't show them on a two-dimensional graph. Output is whatever the firm produces per time period. For Ford, so many cars per month or per year. For us, so many cookies per day. So a firm here produces 500 cookies per day with one oven and, let's say, 2 chefs. That's the amount of labor they have. That's the amount of capital they have. Now imagine we have an equation, 500 cookies, Q, equals 2L and 1K. So in other words, 2 chefs, 2 units of labor, and 1 oven, 1 unit of capital here, will be able to help us produce 500 cookies per day. This is a kind of production function, ignoring enterprise and land. And of course we can switch that around if we want to and make it Q equals 2L divided by 500 plus 1K over 500. And then we have a production function of Q expressed as a function of L and K. So we can write our production function as something like this in more mathematical terms. Q is a function of K and L. So Q is a function of K and L. if you were to double the inputs, so now you have 4 units of labor and 2 units of capital, what would you expect to happen? Well, you're going to get more cookies, I expect, but it may not be 1,000. It could be more than 1,000, and it could be less than 1,000. And that's a topic we come back to later, where we look at the returns to scale. Okay? If we double the inputs and the output also doubles, we have constant returns to scale, and if not, situation. We just talked about isoquants, and the isoquant that we drew was roughly convex to the origin. My drawing's not too good here, but you can see it's pretty much convex to the origin, and that implies a certain relationship that, you know, as you have less of one factor of production, okay, as you have less, for example, labor, you're going to have to substitute with less capital here, sorry, you're going to have more labor. So you can have less ovens, for example, let's say half an oven, but you need to have 3 chefs. Or you can have less labor, let's say you have 1 chef, and then you have to have, for example, 3 ovens. So here, capital and labor are to some extent substitutable, because we can still produce our 500 cookies by having less capital, less ovens, but we must substitute for the loss of the ovens by having extra labor, and vice versa. So labor and capital are to some extent substitutable in the production of cookies. And we say here that when the curve is convex to the origin, then the relationship is one where the resources are not perfect substitutes. That, for example, as we lose a certain amount of capital here, we have to substitute with a certain amount of labor. But down here, when we lose the same amount of capital, we have to substitute with a lot more labor. And that's because of what we call diminishing marginal returns to labor, or to any factor of production. We still need capital, and right down here we've lost a lot of capital, and it's more difficult for labor to substitute, so you need even more labor than before to substitute for the same loss of capital. So when you have a convex to the origin isoquant, it implies that the factors of production are imperfectly substitutable. Now, that is not always the case. There are different scenarios, and these isoquants can actually have different shapes. And examiners do like to ask about that in multiple choice questions. So I have 2 different scenarios coming up here. The first one is where capital and labor, okay, can be perfect substitutes, not imperfect. So cookies can be cooked with extra ovens and less labor, or more labor and less capital. And even we can have a situation where we use only capital or only labor. And we show this, I'm wondering if you can actually guess before I demonstrate, before I show it. I'll give you a few seconds to think about it. What shape do you think the isoquant will be when capital and labor are perfect substitutes? Okay, I'm going to click in about, what do you think, 5 seconds? Okay, 1, 2, 3, 4, 5. There you go. Okay, so here capital and labor are perfect substitutes. You can produce cookies with only capital or only labor. And as you lose a certain amount of capital, the amount of labor you require per unit of capital lost will always be the same, because in this scenario, labor and capital are perfect substitutes. May not be too realistic, but we do learn these theoretical paradigms often to contrast with more realistic situations. Maybe a more realistic one in certain situations is the one coming up now. Here we have capital and labor, which must be employed in fixed proportions. And one factor of production cannot substitute for the other one at all. So here production is according to fixed proportions of capital and labor. Now I wonder if you can guess what it looks like here. I'm going to give you up to 10 seconds to work it out. Okay, I'm going to count to myself 10 seconds. That's 3, 8, 9, 10. Here we go. It's actually L-shaped. And the reason is that the firm needs to have this much capital. It could be a certain amount of oven space for a tray of cookies and a certain amount of labor in terms of minutes required to get the to do the food preparation and put the tray of uncooked mixture into the oven for baking. And if you want to produce more cookies, there's frankly no point having an extra oven, or there's no point in having extra labor. There's simply no point. You need to have a fixed amount of capital and labor. If you want to produce more cookies, then you move on to a new isoquant, which will also be kind of L-shaped like that. And again, you're going to produce here. So your production function will just be a line that draws together and goes through all of these different points where the right angle is formed. Okay, there's no point employing more capital than you need because you're going to increase your costs, and there's no point similarly of using more labor because again you're going to have higher cost. Right, so there we have two different scenarios. Do learn them and understand them for multiple questions in particular. Okay, now in the long term, we are focusing in this presentation only on the long term, and I have a separate presentation just for the short term for you to separate out the thought processes that you have completely on these two topics. Okay, it's very important to distinguish between the long term and the short term in economics. There's actually no time period specified in economics for that. The long term is a time period in which all factors of production are variable. There are no fixed factors. You can have more ovens and more chefs and more land and more enterprise as much as you want and in any combination that you want. You can double them all, you can triple them all, you can halve them all or make them 1/3. You have that flexibility. The short term is defined as a period when at least one of those factors is fixed in supply, and that's the topic of a whole different presentation. Right, here we're going to just clarify graphically a bit more on isoquants and on different production functions that reflect different production methods. So here we have an isoquant which represents a production of 500 cookies per day, and we have two different production methods. So the convex to the origin curve here containing AC, there's A and there's C, represents different ways of producing 500 cookies per day. So it's called an isoquant, equal quantity, isoquant. Point A over here is a relatively capital intensive method of production. TP1, that we're going to see in a minute, traces out a long run production function using capital intensive means of production. There we have a new isoquant with a higher level of production, and there you have the production function, which is TP1, using relatively high amounts of capital and relatively low amounts of labor. So it could be, for example, that you have 2 ovens and 1 chef. Let's call that the relatively capital intensive means of production of our 500 cookies per day. Now, it may be that in the particular country you live in, the price of capital happens to be relatively high. It could be a country where capital is relatively scarce, not abundant. And therefore, for a firm maximizing profits, it might make more sense rationally for profit maximization to use a different method of production. So where labor costs are relatively lower than capital costs, in other words, the relative price of labor is lower, then it makes sense to use a different production method, which is TP2, going through points C and D. We're still producing 500 and 1000, but we're using a different production method. We're going to use more labor. We have another chef over here, and we're going to get rid of 1 oven. So we're now going to have 2 units of labor and 1 unit of capital for the same output. So point C there represents a relatively labour-intensive method of production, and TP2 here traces out a long-run production function using labour-intensive means of production, and which one the firm chooses will depend upon the relative price of factors of production. Okay? Understand and learn the method of discussion. Terms like relative price of factors of production, isoquants, production functions. All these terms are critical because in almost every single assessment you're going to be asked for some kind of discussion as well. Even of course with advanced placement you're going to have more weight given to multiple choice questions, but you still have 30% given to structured questions.